Hello everyone, I welcome you all to this new lecture series on computer networks. In this series, we'll be talking about all the fundamental and advanced level concepts of computer networks. In this lecture, I'm just going to introduce the computer network and the fundamental terms of computer networks. So let's discuss what is a computer network. A network you can consider it is the collection of devices. Those are interconnected with the communication links. So the devices we can also called as node. So let's assume that there are devices like, so I assume this is a device or node like this. Okay. So let's say these two are nodes or devices. They want to communicate. Generally, we consider these nodes are computers, but it is not necessary. A node can be a computer or laptop or any device, like it can be a router or mobile phone, smartphone or tablet or any other, let's say printer, which can generate or transmit data and which can receive data. So if I consider this is a sender node and this is a receiver node, or this is a source node or this is a destination node. So let's say I'm saying this is a source node and this is destination. Node, right? So source will send the data and destination will receive the data. In between, there may be other nodes also. So source and destination nodes, these are nodes only. So I'm writing node. We consider these are as end node. But there are intermediate nodes also possible. Like there may be bridges, routers, or transmitters, modem, or a number of other things are there. So let's say this source is transmitting or establishing a channel. A communication channel is there. So there's a communication being established from source to destination. And this may be a bidirectional or unidirectional kind of channel, right? So this is a bidirectional kind of channel. But when a source want to transmit the data, it requires transmitter. Okay. So let's assume there is a transmitter device or transmitter. So from source, there is a device connected, which we are considering as transmitter. And at destination node, it must be having a receiver. So there is a device or node. We are considering it as a receiver. Okay. So this is transmitter and it is a receiver. Why we require transmitters and receivers? Because, so let me write it. And it is receiver. Because the data which is available on the source node, it is in binary format. It is available generally in bits or bytes. But the data cannot be forwarded or propagated on this communication channel. So this is communication link, I'm saying communication link. On this link, the data cannot be forwarded in the native form. The native form is the bits or bytes. So this data which is available here, I'm highlighting, let's say it is forwarding data which is available in terms of bits or bytes. So, and this is the native form of the data. This data cannot be forwarded on this communication channel in its native form. So it needs to be converted into signals, right? There are different types of signals like analog signal or digital signals, but these transmitters will be required to transmit the data from the one form to another, from one source to another node. Okay, so in order to consider that two devices in a network, we need to ensure that the two devices must be able to exchange the information or data. For exchanging information or data, there has to be a communication link or channel, right? And this communication or data exchange or information exchange will be following some set of rules, and those set of rules are considered as protocol. So let's talk about few of the key terms in computer networks. So the very first term is data. What is data? We know that it is the combination or collection of bits. We do have a number of representations of data. Meaningful data we consider as information. And in computer networks, when I say that there is a data interchange, that means information is being interchanged between the source and destination node, right? So before forwarding the data will be transmitted or converted from native form to signal. So the bits to signal conversion will be there, and for that we need some devices like modem which can do that. So the modem will convert the bits to the signals, and at the receiver end it will convert signals to again bits. Now there are different types of nodes. The nodes are like AND nodes. So I'm saying there are different types of nodes. So you can say AND node, or you can say intermediate node. So AND nodes, like the devices which we have, it can be a computer or printer or laptop or smartphone. All such things can become or treated as AND node, which can transmit or receive the data. What are the intermediate node? The intermediate node, like we may have switches in between to forward the data, or we may have routers in between, right? We may have in between different devices, so that will be treated as intermediate. Now the communication medium, in order to establish a network between two devices or node, there has to be a communication medium established, or channel need to be established. So what is communication medium? It provides a way to transfer the information or data. There are two types of communication medium. We have wired medium and wireless. So there are two types, wired and second is wireless. In wired and wireless, the detailed properties and description we will discuss in coming lectures. Okay, so we do understand if we connect two computers with a cable, that cable we consider it is a wired medium. And wireless we understand like we are having Bluetooth or Wi-Fi connectivity we have nowadays, or mobile phones we are using. They communicate by utilizing air as a medium, that is wireless medium. Now what are the signals? Signal, we do understand the fundamental of signal. They have a waveform and they just replicate the same wave in different period. So there are different types of signals. Why we are talking about signals here? Because the data which is being transmitted from source node to destination node, it is available in bits and bytes, and those bits need to be converted into signals. And there are two types of signals. One we consider as analog signals, and another types of signals are digital signals. So because we have discussed digital electronics in detail, you do understand the digital signals. So how do the analog and digital signals they look like? Analog signal, like we have sinusoidal waves or cosine waves. So a signal you can consider here, if I represent, so a signal which may look like this. This is a continuous signal. There is no breaks in between. So such signals you can consider as analog signals. There may be different waveforms, but analog signal are continuous in nature. Now, if we talk about the digital signals they have some discrete nature. So if you consider the signal is high initially or low, it will be high, then it will become zero or low, and then after some time it may again become high, and then again it will become low. Such kind of signals we consider as digital signals. They work in binary 0 and 1. So high voltage level is mapped with some value and low voltage level is mapped with some value. Generally we map like 0 and 1. So this is, let's say, representing 0 level, and this is representing 1 level, and this is the digital signal. We do understand. Now what is the bandwidth? When we transmit the signals in a certain duration, the energy flows. So when energy flows, we check how much energy in that particular duration is being floated, and that is treated as the bandwidth. So let's try to understand. So there are signals we are floating, and there are different energy levels, or you can say voltage level. So a duration which we are taking, the energy level is like, it is a low level, and it is increasing, and then again it is decreasing. I'm taking a one particular slot where the energy level is like the signals energy. I am just drawing here like this, the level of voltage. So this is the energy level in this time frame. Okay, so if this is the energy level, we can represent like this is the amplitude of that signal or energy. So we can write here amplitude. These are the signals or energy levels, or you can say the frequencies, which is being divided over a period of time frame. So this is, let's say, the frequency level, low level, or and this is another frequency, let's say, and the overall thing you are representing as the bandwidth. So on one axis we are taking like frequencies, and another axis we are taking amplitude, and these are the level of frequencies. So if we want to represent the bandwidth, let's say B is the bandwidth, we can be represented like the FH minus FL, the difference of these frequencies. That is the bandwidth. Later on, you'll understand this in detail when we solve the problems. Now let's talk about the transmission media. There are different types of transmission medias. So guided and unguided medias are there. So guided media, so let's say I write one as guided media, and this side I would say unguided. So guided media we consider as wired media, and it is wireless. Right? So these guided media generally are having 2-3 types of wires or cables. So if we want to write those things, we have twisted pairs cable, we have twisted pair cables, coaxial cables, and fiber optics. We will discuss the properties in coming lectures of all these media. In unguided media, we have, you can say, air or atmosphere, which is playing role there as media. So atmosphere you can write. So this is unguided media, or air is there in this media. Now what is a protocol? The protocol, as I told you, it is a set of rules. So when one device is sending the data or transmitting the data for another device, or source node is sending data for the destination node, there are certain rules and regulations. The rules like the data will be sent in which form, how much data at a time can be sent. So if the data is being divided into a small portion, then how the next portion or part will be sent, and so on. So there are different restrictions. All these set of rules we consider as a protocol. So both the parties, both the nodes need to follow those set of rules, right? So we will discuss different protocols like HTTP, FTP, and number of protocols are there. We will discuss a number of protocols. So these are some key terms in computer networks which you need to remember. Now there are certain characteristics of the computer network, or you can say desirable characteristics of a computer network. The very first thing is, in a computer network, we require that the communication need to be fast. It should not be slow. Otherwise, the users will not prefer such kind of network. So fast communication is expected, and it is the property of good network. Sharing of resources, your network must allow sharing of resources. Let's say one printer is there, and if there are different two devices want to access the same printer in same network, there has to be a provision or a protocol or mechanism which allows sharing of data and files. So let's say I am having one big file on my laptop and I want to share with you or a number of people. There has to be a provision so that data or files can be shared. Scalability. So in a computer network, let's say at any point in time I am having n number of nodes, and in case I want to add some more nodes into the network, it should be easily manageable thing. So if I want to expand my network, there has to be a provision to do that. So my network need to be scalable. It should not be saturated, right? So scalability is highly desirable because nowadays we are having ad hoc network, wireless networks. So devices may come and join and leave the network, right? So this is highly expected. Then reliability. The reliability of the data exchange or communication need to be there. If a device is sending a packet or a data unit, it need to be delivered to the other party. If it is not getting delivered, there has to be a mechanism which will intimate the sender and initiate the corrective action. So there has to be a reliability. It should not be like that. One node is sending the data and it is being lost and it is not being intimated or corrective actions has not been initiated. And security. Security is also very prime concern. So what is security? When the data is being shared or forwarded, the data need to be secured so that only authentic or desired user or node capable to read it, capable to, you can say, decrypt it, right? So if security is not there, then the whole network become meaningless. User will not prefer such kind of network where the information is not secured, right? So these are few of the desired properties of the computer networks. So in this, I talked about the introduction of the computer network. There are some key terms of computer networks and the desired properties. So I'm ending this lecture. Thank you. See you in the next class.